Okay, so I'm working through the review for the test because that was kind of a request that I got. Okay, so on this first one it says list the degrees and indicate whether the function is even or odd. So on A we see that our arms are like this, so one's up and one's down. So that means automatically we've got disco arms, so it has to be odd. And the number of degrees, well, that's going to be as the number of zeros potentially. It's also one more than the number of terms. Well, we have 5 zeros here, so we're thinking it's probably a 5th degree. We have 1, 2, 3, 4 turns, so that's definitely a 5th degree. And in this case, it's actually the leading coefficient is going to be negative since it's up to the left and down to the right. For B, we already know that it's an even function because both of the arms are doing the same thing. We've got that going on. We've got 1, 2, 3, 4 zeros. We've got 1, 2, 3 turns. So that means this is going to be a 4th degree. And it's also going to be negative because the arms are face end down. This number C is going to be even again because the arms are doing the same thing. They're both going up, so that means it's going to be the leading coefficient is positive. We've got 1, 2, 3, 4, 5, 6 zeros. So we think it's a 6th degree. We have 1, 2, 3, 4, 5 terms. So yeah, or 5 turns, sorry. So it's a 6th degree. So your n equals 6. So this is n equals 5. This is n equals 4. N equals 6. That's your highest exponent, right? So like the first would be like x to the 6th, plus or minus a whole bunch of things. Okay, this one, we've got the arms doing different things. Our arms doing this, so that means they're odd, because you've got your disco arms. We've got 1, 2, 3, and then we've got 2 turns. So that means we're going to say this is an odd degree. In other words, it's going to be raised to the power of an odd number. And we're going to say this is a 3rd degree polynomial, and it's a positive leading coefficient. Okay, describe the end behavior of the function. So we've got f of x equals negative 2. Well, so okay, we don't care about these numbers here. All we're looking at this is this first one. Okay, so in this case, so our n is our highest exponent. Our n is a 98. That's an even, right? It's divisible by 2. Our leading coefficient, our a, is a negative 2. So then this is even negative. So even negative. What that means is both of the arms are going to do the same thing, but both of the arms are going to be facing down just like that. So that means that if we look at it on a coordinate plane, so like this, it's going to be like this. It's going to do a whole bunch of stuff in the middle that we don't care about, and it's going to go like that. So as x goes, on this one, it's as x goes to the right, y is going down, so that would be negative infinity. And then as x goes to the left, y is also going down, so that's also negative infinity. Okay, so this is our next set of problems. Okay, we're using this function right here to answer these questions. So the first one is, what is the degree of the function above? The degree is this highest exponent, so, and that's our n. So if we look at it, that was ax to the n plus whatever. N is our degree, a is our leading coefficient, so our degree is 5. The next says, what is the leading coefficient? Okay, well, the leading coefficient is our a value, and that's a negative 4, because that's what's out front of this very, very first x term. Now it says, describe the n behavior. Okay, well, so n is a 5. That's an odd number. A is a negative 4, so that's negative. So then if we look at our little table that we made in class, we see that odd functions have the disco arms, and the negative ones means it starts up to the left and down to the right. So that means then, we look at our n behavior, we say as x goes to the right, well, right in the x direction is positive infinity, our y is going, in this case, down. So that's negative infinity. As x goes to the left, so as x approaches negative infinity, whoops, we need a negative there, then in this case y is going up because it's going up to the left, right? So then this is y goes to positive infinity. What's the domain of this function? Okay, so like if we look at this function, it's going to come down this way, like it's going to start up here. It's going to come down, it's going to do some stuff, and then it's going to go down that way. So our domain is our possible x values. This is our domain. there's nothing to keep it from, there's nothing to stop it. So it's going to go from negative infinity all the way to positive infinity. So our domain is all real numbers. So domain equals all real numbers. Or if you wanted to write that out, that's negative infinity to positive infinity. Then it says, what's the range? Well, for range, we're looking in the y direction. There's also nothing to stop this. It goes all the way down to negative infinity, all the way up to positive infinity, so our range is also all real numbers. So this could be negative infinity all the way up to positive infinity. Okay, number 8, it says, what is the multiplicity of the following function? What is the effect of the multiplicity? In other words, does it wiggle, bounce, or does it go straight through? Okay, multiplicity says we want to know how many times a factor is occurring. In this case, we have one factor, we have x plus 3, but it occurs 6 times. So that's really like x plus 3, x plus 3. Let me just copy and paste. We have, copy, paste, ta-da. Okay, that's 4 of them. So this is the same thing as this, right? There are 6 of them. So our multiplicity is 6. In other words, there are 6 of them. And then what's the effect? Well, we said that if it's an even number, it bounces. So that means it's gonna, if this is your factor right there, or your 0 right there, or actually ours is a negative 3, so it's gonna be back here. That means that at this point it's gonna bounce. If it were an odd multiplicity, like a 5 or a 3, then it would wiggle. Or if it was just a 1, it would go straight through. Okay, so looking at this table, we have x plus 5 to the power of 3. Okay, so the degree is how many x's there are. So we have 1x here, but it's raised to the 3rd power, so that means we've got 3 of those. This is like x times x times x. So our degree is 3. The second one, so we have 2 x's here, we have 1x here, so this is 1 plus 2, so it's also 3. This one we have 1x, we have 3 x's because of this. So this is 1, this is 3, and then we have another one here, so this is going to be 1 plus 3 plus 1 is 5. Okay, so we're good on that one. So this first one says, what are the zeros, what's the multiplicity? So to find the 0, this x plus 5 is a factor. So we're going to take x plus 5, we're going to set it equal to 0. If we solve for x, we're going to subtract 5 from both sides. We get x equals negative 5. That's our 0. So we go negative 5. And the multiplicity is 3, because it happens 3 times. Right? It's that same exact factor, it just happened 3 times, so our multiplicity is 3. And draw the graph. So this is at 1, 2, 3, 4, 5. So that's our point. And so it's an odd function, means it's gonna have disco arms. It's positive out front, like there's nothing to make it negative. So that means it's gonna go down, left, up, right. So we're gonna start out down here. Instead of going straight through like that, because there are 5 of them, we're gonna go up, we're gonna wiggle, and then keep going up. So we're wiggling straight through that point. Okay, right here, we're going to solve our factors again. So if we set each one of these equal to 0 and solve for our x, we get x equals negative 4 on this one, and we get x equals positive 2 here. So our zeros are negative 4 and positive 2. So negative 4, positive 2. Negative 4, there's only one of those, so it's multiplicity of 1. The other one, there are 2 of those, so multiplicity of 2. This one's going to go straight through. This one's going to bounce. And this one wiggles. So then on our graph, and that's kind of a small space, let me draw it down here. So on our graph here, we have a 0 at negative 4, so 1, 2, 3, 4, we have a 0. We have a 0 at positive 2. It's a multiplicity of 3. That means it's going to have our disco arms. Leading coefficient is positive, so it's going to be that shape. So we're going to go up through negative 4. So we're going to go up, we're going to turn around, we're going to come down, only instead of going through that one, we're bouncing off of it. So it goes like that. That's our graph. Let me change colors to do the next one. So, okay, the next one we have 3 different factors. So we're going to set each one equal to 0. Oops, that didn't turn out right. Equal to 0, equal to 0. So if we subtract 3 here, we get x equals negative 3. we get x equals positive 2, and we get x equals negative 4. So we have negative 3, 2, negative 4. So negative 3, 2, negative 4. Negative 3 happens one time. A positive 2 happens 3 times. And negative 4 happens one time. So the first two, our negative 3 and negative 4, are going to go straight through. This one is going to wiggle. So what you have then is we have 1, 2, 3, 4. 1, 2. It's a multiplicity of 5. Leading coefficient is positive, so that means it's going to be like that. So we have a point here, we have a point here, we have a point here. It's going to go, starting from down to the left, we're going to go up, we're going to go straight through this. We're going to turn, we're going to go down through this. We're going to turn, but we're not going to go straight like that. We're going to, let it go up, we're going to go through, we're going to turn, and let me start over. So from here, instead of going straight up through that, we're going to wiggle. So this is going to go up, and then it's going to do like a little, like it's changing its mind, and then it keeps going. Which is kind of hard to see in this drawing, but you can see that it wiggles. So that would be the graph for that one. So this graph goes here. And then the purple graph goes up there. Okay, so that's your review. Those were all the questions.